Hello, hello. Congrats. You made it through the week. Today we found 302 fresh AI papers on ArXiv. We picked 20 that stood out to us. So grab your favorite snack, get comfy, and let's dive in.
Researchers at Google DeepMind and the University of Cambridge, along with other institutions, improved alpha geometry. It now solves 84% of IMO geometry problems, 2000 to 2024, exceeding the average gold medalist score. This was achieved by expanding the language to handle object movement and linear equations, and using a new search algorithm. Researchers at MIT and UIUC, along with scientists at Meta, developed heterogeneous masked autoregression, HMA. This new model generates realistic robot videos 15 times faster than previous methods. It handles different robot actions efficiently using separate encoders and decoders. Researchers at the University of Washington created RealEdit, a massive image editing dataset from Reddit. It has 151,000 images with real user requests and edits, unlike previous datasets. Their new model outperforms others by up to 165 ELO points in human tests. Researchers at UC Berkeley and Carnegie Mellon University, along with colleagues from other institutions, studied value-based deep reinforcement learning. They found predictable scaling relationships between data, compute, and hyperparameters like the updates to data (UTD) ratio. Their models accurately predict resource needs for higher performance levels. Researchers at UC Berkeley and TUM, along with a team from ETH Zurich and Stanford, developed VectorQ. It's a new semantic prompt caching system that uses adaptive thresholds, unlike older systems. VectorQ got up to a 12x increase in cache hits and reduced errors by up to 92%. Researchers at Tsinghua University and Tencent Hunyuan Research, along with colleagues from NTU, developed OLA, a new omni-modal language model. OLA uses a progressive training method, starting with images and text, then adding speech and video. This approach helps OLA achieve 68.4% accuracy on the video MME benchmark, using only 7 billion parameters. Researchers at Carnegie Mellon University studied private data shuffling in machine learning. They found that standard shuffling methods, DP Shuffle G, have worse privacy than DPSGD. Their new method, Interleaved Shuffle G, uses public data to improve privacy and accuracy. DP Shuffle G's excess risk is EO, N caret 2/3, D caret 4/3, square root pi, while DPSGD's is EO square root D N pi. Researchers at University College London developed a new way to find anomalies in big datasets. They use dimensionality reduction to create a manifold, then look for anomalies both on and off this manifold. This boosted recall by up to 16% in tests on MNIST data. Researchers at NVIDIA developed FIG-Conv, a new neural network for automotive CFD. Unlike previous methods with cubic complexity, FIG-Conv achieves quadratic complexity, improving speed and accuracy. On the Drive AirNet dataset, it showed a 40% improvement in relative mean squared error for drag prediction. Researchers at Harvard Medical School and MIT developed CLEF, a new model for editing time series data. Unlike other methods, CLEF allows precise edits at any time point, improving accuracy by up to 65.71% in some cases. CLEF learns temporal concepts to make sure changes are realistic. Researchers at Peking University and StepFun, along with a team from Lightelligence Private Limited, Present Infinite POD. This new architecture for LLM training uses optical circuit switching in each transceiver, creating dynamic rings. This improves fault tolerance, achieving a near zero, 0.44% GPU waste ratio compared to existing systems. Researchers at Princeton University and the University of Chicago, along with Google DeepMind, developed a new defense against evolving attacks on machine learning models. Their continual robust training method adapts to new attacks via fine-tuning, improving union accuracy by 5.48% across 100+ attack combinations. Researchers at NVIDIA created eClair, a new document-level OCR model. Unlike others, eClair extracts formatted text, bounding boxes, and semantic classes all at once. It was trained on a 5 million page dataset and outperforms existing methods on key metrics. Researchers at the Max Planck Institute and the University of Tübingen studied how similar large language models, LLMs, are. They created CAPA, a new metric showing that LLM mistakes are becoming more alike as models get better. This 84% correlation between judge scores and model similarity highlights a concerning trend. Researchers at the University of Chicago and Google DeepMind created TAIL-OPT, a new framework for training large models. It uses a clever clipping method called bit-squared clip to handle heavy-tailed noise efficiently. Bi-squared clip gets Atom-like performance without the extra memory or communication costs. Researchers at UC San Diego and Stanford University developed EXP Proof, a system using zero-knowledge proofs to verify AI explanations without revealing the model. EXP Proof achieves proof generation in under 1.5 minutes and verification in 0.12 seconds, addressing adversarial manipulation in confidential models. Researchers at the University of Chicago and the University of Michigan, along with other institutions, studied how radiologists use cancer diagnosis. They found that while AI helps, doctors often under-rely on it, even with performance feedback. The AI's AUROC was 0.73 and 0.79 in the two studies. Researchers at the University of Cambridge and Toyota Motor Europe developed Low-RSU, a new method for updating vision language models. It only updates the image encoder, making it 25 times faster than updating the whole model, without losing accuracy. This is different from other methods that update the language model. Researchers at Stanford University developed RAD, a new robot learning method. It uses language-based reasoning from 3,377 human videos to train robots. This is different from methods that extract hand poses, improving generalization to unseen tasks by 15%.
That's the end of today's paper highlights. Great job you made it this far. Now go conquer your day!